everyone. Today I will be talking with Bonaventure on advances in NLP for African languages. Um, a little bit biography about us. Bonaventure is a master's student at Jacobs University Bremen and also a research intern at Miller. His research areas span from machine deep learning applications to natural language processing, applications in healthcare, and African NLP, that's NLP for African languages. I am also a master's student. I study at the Technical University of Munich, Germany. I am a working student at Siemens and a Miller research intern. And my research areas also span from machine learning, reinforcement learning, and NLP, and everything that has to do with NLP and speech and language processing too. And finally, African NLP. So we both work on this thing called African NLP, which is NLP for African languages, and we're part of this larger community that is doing stuff on African languages. This community is called Masakhane. So in this today we'll be talking about generally the state of the previous state of NLP in African languages and some of the things we have done to help boost the state of NLP in African languages, and finally, NLP Masakhane. So some of the things we have done to boost the states are the FFR Translate and Okube. And finally, after that, so we will talk about these two projects. And after that, we will talk a bit about Masakhane. So stay tuned and have fun. So we start with FFR Translate and we give a little motivation. FFR Translate was the first project that Bona and I worked on while undergraduate students. And the motivation behind that is the motivation behind us joining African NLP and the motivation behind the need for research in African languages. Africa has over 2,000 languages. That's one thing. But when you look at the state of language technologies and the 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 amount of African languages that are being reflected on these language technologies, it's almost zero to nothing. In the same way, when you look at um, so things like translation machines, things like Siri, these are language technologies, and African languages, unfortunately and unfortunately, aren't really represented well there. So for example, with Google Translate, we have just barely about 13 African languages there. And with other translation engines, it's almost nothing. So we believe also, before going into what we believe, another thing to look at is like on the internet, when you look at the amount of the presence of African languages, it's also very small. I mean, compared to other high resource languages like English, German, French, and the rest. So there is this need to, and I mean, AI fairness and AI democracy, it's all about including as many people as possible with something. So when it comes to AI, we believe that it's very important to try to include African languages on the NLP map. African languages need to be worked on, and since like major companies or people won't work on it, so we African researchers who speak these native languages could try to do something towards helping to promote our African native languages on the NLP map. So this is our journey, and with FFR Translate, a little recap about African languages, and one of their peculiarities that so there are over 2,000 languages, and there are like so many about how many is this? Six groups. And when you go through each group, you have like let me show you. So you have like a subgroup. So each group has a sub, like we start with the Niger Congo, Atlantic Congo. So I'm trying to show you how we go to the language that we're using for the FFR Translate. So we have the Atlantic Congo, we have Volta Niger, we have the Bay clusters, and after the Bay clusters, we have Fon. So this shows you how complex and extremely diverse African languages are. And this is one of the interesting things about working with African languages. And so in the next, I will talk about, Bonaventure would talk about the data set for our project FFR Translate. FFR means Fon to French. So it's building a translation engine for Fon, which is Bonaventure's native language, to French. And then, of course, there is my native language there in under here. And so Bonaventure will talk about the data set collection, because to build a translation engine, you need to have the data, you need to get the data, and then you need to find the best type structure or architecture of the model, and then you train the model. So Bonaventure will talk about the data set and the architecture of the model. Hello, Bonaventure, you there? You are muted.
Thank you. Oh, sorry, it was technical issue. So thank you very much for your nice introduction. Yeah, so here before
Bona, I can't seem to hear you well. I don't know if it's the same for the others.
Yeah, I have some problems. I think the voice kind of like broken up.
And now, it's the same problem. Something about the mic.
Yeah, it,
Yeah, Alexander says feedback from your speaker to your mic. Maybe if you have an earphone or something. Maybe while you're trying to figure it out, I can talk a little bit so that we don't. And then when you get it done, you just hop in. Is that okay with you, Bona? Says he can unmute himself.
so can you hear me now?
Yeah,
oh,
perfect.
okay, much better.
Yeah, okay. So um yeah, so about the data set, we had to look first of all for data, otherwise we could not pretend to build a good neural machine translation for such a low resource language. For spoken only by like 2 millions, and most spoken language in my country when we discovered the colonial language, which is French. So we had work on the FFR data set. We had initially two versions, sorry, the FFR 1 and 2. Um, the major sources were Jehovah's, like the Jehovah's Witnesses that contain most likely biblical content. And the second source was Benin Law, which is a platform where people are trying to promote the language with short sentences, long sentences, proverbs, and also some books of the Bible joined by JW. So when we roughly pull up all those data together, we got the first FFR data set that we call here after FR1. And the major problem we had with it was some sentences like mismatching, like we can have a French sentence or a French sentence and an incorrect translation for from or for French, or we'll have incomplete or inexistent translation. So we have sentences in French, for example, we don't have his parallel translation in French or vice versa. So for that, to remedy that, we had not to include humans into the evaluation, into the cleaning process, into purging and improving the quality of the data set. And that's what led us to the FFR data set 2, that you can see the number of sentences, or the big size drastically dropped Like from 89,000, we just went back to 27,000, but the quality improved. That's what will be also confirmed like in the next slide, where, for instance, for the model, since we're trying to do something of, yeah, Chris, you can move to it. Since we're trying to do something more like a proof of concept, so we used basically the normal, the basic encoder decoder model for the language, and we try different experiments, try different architectures, try different combinations. And of course, since we're coming at stage where like the attention mechanism was something very hard, something very that had been proved very efficient for neural machine translation, so we also included it. So you will see plus DE and minus DE. Plus DE basically stands for diacritical encoding, which is basically like encoding the characters with diacritics. That just mean basically like those derived from accent on the words. They have high importance. So for instance, there's an example that I can take the word TO, for instance. If TO has 4 different ramifications, I mean, as far as I know, there are many more. A good example that I like to take is those 4 ones. So TO with an accent, we can pronounce it to, which means father. Another accent, another diacritics can give the meaning to, which means country. Another one can give the meaning to, which means sea, and another one can give the meaning to, which means country. So you see that when you strip off those different accents, then you just come back to normal ASCII preprocessing, you have just TO. And actually, it does not make much sense because you lose all the context. So if you're trying to translate father and then you have just TO, you actually don't really know. Human, I mean, even when we are talking, even when we human are talking, we don't actually really know what to go for. So we lose this and we lose the whole meaning of the sentence. So that still applies to neural machine translation. And that's one of the first things that we were trying to prove. And like you can see, no, Chris, please come back. Like you can see the result, for instance, for diacritical encoding is way higher than the result for diacritical encoding. And when I was talking about the quality, you will see that from the data set from FFR1 to the FFR2, the result either the blue or the glue, which is a metric developed by Google, have greatly improved. So yeah, yes, thank you. So that's basically how we've been evolving with FFR dataset. Basically collaborating, we set out to collaborate more with native speakers, and that's what led to another version of the dataset that actually is the one that we use for the website, which was most likely focused on the daily dialogue. So what we did was creating forms and approaching people and asking them for like 5, 10, 20, or 25 sentences they use the most every day. So we shared it on social networks, and after now we gathered all those data together, and then we purged it with the help of the native speakers, sorry. And this actually increased because we wanted something that is much more focused, like what we are talking about daily. We had good data, but it was most likely Bible focused, which is not a topic people discuss or talk about all day long. So we try to shift a bit the concentration of the domain. So as of now, we had, I think, Chris, you are going a little bit too fast. Yeah. So as of now, we have only the encoder decoder part, and one of the major progress that we want to, or ideas we want to try out, the monolingual data that have been proven. to be very efficient. We also want to try the data architecture for low resource language that we use for instance back translation, and also explore other architectures like transformers and everything. There are also technicalization methods like the web that we introduced and we presented at EACM that show very significant improvement, not only on the translation, but also on the transcreation, which is a kind of translation, but takes into account the whole context, the whole culture, and everything that goes with the language. So it's not only like literally translating one word of a language into another word of another language. And of course, we now try to move to communication to machines that can translate between African languages. So we did Fon French. Now we are going to do between African languages, and the first step is going to be both the language with both varieties of so Fon for to Igbo and vice versa. So here is just a condensed video of what the website looks like. So users can enter the sentence in French and have it in Fon, or type it in Fon and have it in French. So for Fon, first, we also created the keyboard, which is on the Google Play Store. To make it a little bit much more fun, we added the button Surprise Me. So for instance, if you selected Surprise French, you click on Surprise Me, what will happen is you will have a sentence generated in French and its translation back down in Fon. And it should be the opposite when you, for instance, you select Fon and you will have the translation in French. Now, I think I might be going too fast, but the other part we included in the other stuff feature we included on the website was the possibility for the users to participate, to help improve the model. And they can do that by suggesting translation. So in case they were expecting a translation that they did not get, for instance, so they can suggest that translation and give a score of, let me say, translation score, or that we can also call it score, confidence score, how much they are, that the sentence they are translating, they are giving us, they are suggesting us is efficient, is good enough. So yeah, that's basically, of course, one can type like we can see there, like Bonaventure, and then you can translate and everything. So yeah, that's basically about the FFR Translate that we have that got huge feedback from the public, more even than what we thought. And I think Chris will take it from here.
Thank you very much, Bonaventure. So when we had this idea, the idea FFR stemmed from a vision that we had. Imagine a future where you can talk with your Siri or your Alexa in an African language. Also imagine a future where you can also learn more, have more exposure to African languages on the internet and or in the media. So it's very important for people, native speakers or non-native speakers, NLP researchers to work on trying to incorporate as many as many world languages as possible. And we're just African native speakers trying to do that for our language. When we started with the idea of FFR, with the paper and the workshop in iClear, we got a feature from BBC, um, as, together with Dr. Ignatius and his work on Igbo, and Jade and from Masakhane. We also got a feature from Voice of America, Afrotech. We got a feature from AI Expo Africa, where we wrote an article on that. We got a feature from Germany, and this interesting way of like just want to have fun with the FON. And we got a feature from Russia. We were undergraduate students in Russia, and we got a feature from Russia. I think it was Moscow or St. Petersburg. I'm not sure. We got a feature from Benin. That's oh, I should remove the audio. That's Bona's country, where majority of Fon speakers are, and they really love the idea and put it on the TV show, and encourage users and organizations to use it. It was it was really beautiful getting this feedback, because it showed that this idea we had, or this thing we're doing, was really important, not just for our African languages, but for African languages in general, and not just for only African languages, but for like the world languages. So this pushed us to work towards incorporating more African languages. So as Bona said, starting with Igbo, we plan to add more languages of Africa, and from there, more languages of the world. Yeah. So we started with the plan for more African languages. And bear in mind that for the FFR that we did, right, we were only students, and we had no access to huge GPUs and TPUs like big companies. So we had to find a way to make do with the little resources we had with good old collab. We had to manage even the RAM. We had to tweak the model architecture and make it lighter. So it takes a lot of resources, and it has taken a lot of resources from us doing this, but we did this and we continue to do it because of the passion we have for NLP and the desire to add languages in NLP. So we created a GoFundMe for donations, a collaboration for the future work of incorporating more African languages to FFR Translate, to the future work of preserving African languages and putting them on the NLP map. And now we move to Okube, because um, so in languages, there is text and there is speech, right? These are one of the two main ways we communicate. And where there have been many works on text to text translation, but there's been few works on speech, on incorporating speech. Also, African languages, like the African culture, if you look at the African culture, we pass information, or values, and the things are passed down to generation through audio media. So like through songs, through stories, and that's why we believe that the future of African languages, or even languages in general, lies on the speech. And now we will be talking about another project called Okube, which involves the speech of Fon and Igbo.
Okay, so I think I take it from here. So Okugbe is the concatenation of two words, Oku and Gbe. Oku is from a place, mother tongue, like Igbo. That means speak. I mean, speech, expression. And Gbe, that means like language or langue in French. So, like Chris explained, the idea is like to build ASR, automatic speech recognition technologies for African languages, which is actually uh, at this date very practically inexistent. So one of the major goals that favorize or that goes along with our idea is the one by Nelson Mandela. Actually, everybody knows about him. That says that if we say something in a language, I mean, if we talk to people sorry, in the language they understand, then it goes directly to their head, the brain, the processes. But then when we talk to them in the native language, it goes straight to the heart. And in my native language, Fon, there's something that's say, I mean, there's a say like nueve numero, that means that what is dear to you, you only know actually how to express it very well, precisely, with all the emotions and everything that goes with using your native language. So saying that, like we mentioned earlier, we had problem because those languages, our language in Africa, are most likely taught. Like Chris said, we will have real people, grandfathers, grandmothers, people sharing histories around fires and everything. So it's not by writing, it's by speaking. And the second thing is There are no research actually done in those languages, or few, very, 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 very few. But we want to make AI, in fact, everybody wants to make AI okay and usable, profitable for all kind of, let me say, language and everything. So we have also to make sure, have to do our own, our duty, to make sure that Africans also have the place, the word to say in the whole pool. And then for Okube, our main contribution is from the paper is the very detailed linguistic understanding, linguistic information we gave about both languages. So we are not linguists, but it was very interesting. It was very needy to go down and to understand how it works, like how many tones we have, how many characters we have, and everything, code switching. I think Chris will talk about all of those things. And then we created, after those deep analysis, we created two ASC. There's one for Fon, one for Igbo. So for Fon, there's been by a professor of mine, a former professor of mine, uh, and our model that we built outperformed his. That was actually before wow, the only one that has been done in the Fon. And for Igbo, then the result that we obtained serves as benchmark. So we had some hurdles with the Igbo model. It's anything that will be explained later. So the results, why we are trying to improve, can be also already used as benchmark for other people to work on Igbo, use what we have done, reproduce and improve it. So now, in case we take the floor and talk about briefly the linguistic background, explain what we have now.
Okay, so I will try to be a little bit fast because like the main information is here. The linguistic analysis of Fon and Igbo serves to help us better understand how Fon and Igbo work or how they behave in order to better design this speech recognition model for them. So they have a lot of some similarities. They're both tonal. They have some differences like the Latin structure in the alphabet besides Latin in Fon and the lack of it here. They have a major difference, which is code switching. So Fon has no instance of code switching, while it's very common in Igbo, and it affects the way the language is spoken in the data set. The next thing is getting the data set for these languages, because for anything that has to do with AI, you need data for it. Unfortunately, we discovered that there is very little data set for both Fon and Igbo. So for Fon, we used, like Bona said, there's a baseline done by a researcher, Dr. Laleye, before in the past. So, and due to the open source of the data set and the code, we're able to use the data. Unfortunately for Igbo, to this day, there's no open source Igbo speech corpora as far as we know, and we're still sourcing for it. And as a matter of fact, we started we set up a process to gather and compile and release this data set. So these are the data sets, about 10 hours for Fon and about 2.5 for Igbo. And then just pre-processing. Pre-processing is an important stage in modeling to allow the model to understand the data that you're giving it. So for the speech is the usual sampling rate and the Fourier transformation. And for the text now, this is an important part of our research is on analyzing the impact of diacritics on the model. So this is the example Bona gave with how diacritics help give meaning to the words. And this is very important, especially when you're speaking. So after that, Bonaventure now will talk about the model, experiments, and briefly, and the results.
Yeah, so here, to make it brief, we try different combinations with those two main components: the residual convolutional networks, the bidirectional recurrent neural networks, ICM GRUs, and we put in we actually try to customize, because most of the time when we use the self-attention, whether it's self-attention, whether or is additive attention or the bidirectional attention, is most likely on the NLP context. So we tried to apply the context. We had some hurdles. We tried to customize them to our needs. So for that, we tried these 4 different combinations. Like islands were always at the input because we had speech. So like Chris mentioned earlier, we had to transform those speeches using the fast Fourier transformation. We had to transform them into spectrograms, which are 3D pictures that shows the evolution and the density, everything on the project. Much more a meaningful representation about the speech, about density, the amplitude, and everything. So and we made sure that the information is not lost. So here is basically the picture of the model, the overall picture. So like I was saying, at the output, we have a spectrogram, or to be more specific, a narrow band spectrogram. We have 2 different kinds of spectrogram. This kind of spectrogram, the narrow band, is the one, the type that helps us achieve much more result. Then follows the radio CNN block, in which first of all we normalize the features before feeding them to the common layers, and then after we flatten, we take it, then we feed them to a dense layer, and then we go next to the ballistic networks and everything. So we have 5 blocks of CNN, 3 blocks of Balastian, and 3 blocks of GIUs. So the attention mechanism was implemented on the decoder size, which is in our case the BRGIU. And the theoretical intuition or idea is that since we are using the CTC laws, the attention was trying to force somehow the decoder to make some monotonic alignment, which actually is supposed and have actually given better result, like improve the transcription of the speech. So like in this picture, we can see that for both Igbo and Fon, inputting using the attention decrease the word error rate, which is the matrix that we use here. So the lower the better. So we can see that it decreased at least from other kind of combination with the attention decrease at least of 5-6% for both languages. And as I was saying, since we had the baseline for Fon, our model outperformed that baseline. And yeah, so I mentioned earlier some problem that we also, first of all, I can explain
sorry, I can go back if it's a mistake.
No, it's fine, it's fine.
Okay.
I was to you about the explanation of the Igbo's high small
okay.
okay. Fast. So here we can see that basically translation actually is almost, I won't say perfect, but it's excellent. Because for instance, the second sentence which says like, no, please give sell me porridge. That's what it is. But you can see down the predation part, a has been inserted. So that insertion actually, which is also a part of, so to compute the word rate, we use the deletion, we use the insertion, we use the replacement, and there are things like that. So an insertion, a deletion can also actually affect that. The next sentence, like Fitea goes in, which means from where are you going to? Like from where have you, from where do you live and where are you going to? And we can see that a blank of the target, we're expecting we'll see like 2 different blank character inside, but then on the prediction part, it has been condensed into one. Again, as I'm saying, on the speech part, you will not be able to identify those. Anyway, when someone says Fitea goes simple, like you understand actually the whole message, the whole idea is going, that is to be transmitted. So you don't actually care about the transcription. And the 2 other sentences can show that on, respectively, the prediction, we got predictions with some diacritics, or in some case without diacritics, while on target we were expecting sentences without diacritics. So those actually, let me just call them plays, games of the characters, like insertion, deletion, or moving around can really affect the word rate that we have. But except that on the speech part, everything's okay. So the code, we made them open source. People can use them. People can have a model. We try to build a very self-explanatory, very detailed notebooks, code, so that everybody can just easily go through it, get the data, and then already get started or use what we have and improve already from there. So yeah, Krista, we take on and we can move it.
Thank you very much, Mona. So I will briefly talk about the second analysis, which involves the diacritics. So as Bona explained, CER is just like measuring the error rate between the target and prediction on a character level. So if you have like font, it's measuring the F, the O, and the N, while word error rate is on a word level. So we discover that the font, the margin between the CR and WR of font, it's so big compared to, for example, the margin between Igbo, CR and WER of Igbo. And we tried to do some analysis on that. And this analysis led us to the impact of diacritics. So the idea is the font, which has the diacritics encoded, has a much larger character set. So it has the alphabets plus diacritic for each of the alphabet that has diacritic. So like you have an A, and then you have the A, asontego, asongraph, asonsecunflex, and everything in the character set. So that means the model has more to learn, although the model ends up being more representative. Whereas in Igbo, where the diacritics have been stripped off, so the model isn't learning the diacritic, it's just learning the plain alphabets. It has a much smaller character set, and it's much easier for it to learn. That's why, for example, for these examples that Bona gave, we see that on a word level, they're okay, and they look okay and correct and manageable. But when you look on a character level, that's when you notice the subtle differences. So like you have the E and you have the Asantego, or you have the space and the no space. So this leads us to this helps us to understand the impact of diacritics on the model. Also with tests that we did with evaluation tests we did with native speakers who listened to the audio and looked at the text transcript, we discovered that the model on the diacritics was able to learn this diacritical information about the word, like how the to with the asantego means something different, unlike the model without diacritics encoded in it. So that's it about the two projects that we did, two advances to help African NLP in general. And we'll end by talking about a much larger community which we are part of, which is inspired and determined to work towards putting African NLP on the online map, and that's Masakhane. So Masakhane is an online community at the website masakhane.io. We joined as undergraduate students, Bona and I, and since then we've met like very experienced, wonderful experts who are so loving, so kind, and it's like a community where everyone is growing together and pushing each other forward. So we've worked at Masakhane as a community, we've worked on the idea of participatory research in NLP, especially for machine translation. So participatory research involves where all the processes involved in machine translation. So from collecting the data, the content creators, to the machine learning experts or researchers who train the model, to the evaluators who are best if they are the native speakers of the language, who can really tell you what's wrong and what's not working well in this model's output. So a situation where all these different factors and processes are brought together, working under one community and working harmoniously, and that's Masakhane. So recently we received the Wikimedia Foundation Research Award of the Year 2021 for paper on participatory research. We have over 700 members made up of experts and professors, and MSc students, research scientists, like everyone and anyone is welcome to join Masakhane. So with that, we end by saying thank you very much for your attention in English, and Dalo in Igbo, which is a way of expressing gratitude. And in Fon,
And fun is actually
and
search.
then Chunumi.
We will
Okay,
just
thank you. Dalo and then Chunumi. Merci beaucoup. Dankeschön.
Wait, thanks. We all suddenly learn quite many ways to say thank you, I guess. Okay, great. Let's go over the questions. I see some of the questions in the chat. Maybe you can just go over one by one. And also just a quick reminder, everyone, you feel free to post your questions in the chat. If you prefer speak to ask questions, just raise your hand. Actually, you can unmute yourself right now, so you can use your mic to ask questions or make any comments.
So I found out it was sorry. Ask if the ASR reduce when we use pre-trained. I guess you wanted to say pre-trained network or model architecture. So exactly. So if that's what you're talking about, yes, we use exactly the wave to vec. We took part in the sprint, and yeah, the model rate actually decreased, and from 42 we reached, I think, 1490 something. And here's I'll paste the link inside the chat that you can go and check. So yes, using a pre-trained model really reduce the whatever rate and increase the transcription quality, especially with to like you mentioned of Hugging Face.
Yes,
So,
that's true.
So what is the best way for the ideas in the US to help out with your project and with Masakhane? So with our project, like we showed earlier, it will be good. Like if you want to help, you can help ideas. For instance, some people suggested to use a way which is a closed language to Fon, and try to do some alignment or some augmentations the data. Or you can also, like we shared on our GoFundMe, you can also try to support us, because it also matters the computational power. For instance, from the for Okube, we had, for instance, the Professor Graham from CMU, who actually we really want to thank, because he had to get for us especially a Amazon instance that was very, very, very needy and very expensive. So we wouldn't have done it so easily, just like with normal Google Collab and everything. And for Masakhane, I mean, we are just two members, so we are representative. But if you want to help the whole itinerary, so people are working on many languages, people are working on different languages, and there are not only people from Africa, there are people from all around the world. People are working on name entity recognitions, people are working on speech analysis on speech synthesis. I think a lot of pool actually of variety of subjects of natural language processing. So I would suggest, like, if you really want to contribute, then I will put the link here. So you can go to our website, and there's a Slack link, or maybe I'll try to paste it here. So you can join the Slack. Usually we have our meetings on Tuesdays. On this day, so we had our meetings today, and you can just join. Everybody is welcome to join, and then like introduce himself or herself, and then share his vision. Or you can get into the Slack, present yourself in the introduction channel or general channel, and then speak up. People are very warm, welcoming, and everybody will just like take it from there. That's basically how we got many people from Google, from many people from DeepMind, many people from Hugging Face. That's basically how we got all of them together. And then now we are working on many separate projects. Yes.
Thank you very much. I could do a very quick summary of everything Bona said and just add this in just 2 or 3 points. So how to help our work. One, you can help by promoting our work and promoting works in general on African NLP. So how to promote them. If you are a researcher, an ML researcher, you can try to include African languages in the NLP machine translation or speech task that you are doing. And now you know that if you are including African languages and you need help with anything about African languages, there is Masakhane and there is us to come for any questions. You need help with the data set with native speakers, you can come to Masakhane. If you're not an ML researcher, you can help generally by promoting these works that we researchers are trying to do with African languages. So that's it.
Yeah, and also you don't actually to be a data scientist or researcher now. Like we work with everybody. So linguistics are there, people who linguistics that actually are not researchers, but they know about some properties of the languages. People who are interested in. So for instance, we have weekly tutorial sessions, mentoring sessions, like study NLP, where people like every week have like a task for us. It can be on NMT or it can be on speech and everything. So it's not like compulsory, you have to have all this background, but you just have to have the will. And somehow when you get in, you will be mentored by people experienced that will help you to find your way and your focus and your interest. Yet from there, you can develop yourself, and then the whole community is developing, and we work together and get things done.
Great, that's really sounds exciting. Yeah, I mean that's you guys have a very great effort, joint effort to tackle the challenging problems. Let's say I think there is another one question in the chat asking, is this for developers in UK? I guess this is not specific for one country or
Yeah, it's not specific for one country.
Yeah.
It's not specific. So for instance, we are working on a question answering project with Google, I think of DeepMind based in UK. So that's how basically people join. Like this year we do talks or we talk at conferences this year, and then they're interested, and then they just try, and then from there everything starts. So yeah, you just come with the ideas, and then we brainstorm it, and then we judge how it should be done for everybody to benefit and to learn from it. Yeah, and we are organizing at ES here next and ACL, sorry, the next Thursday, 6th of June. Sorry, we are organizing a session. So it's gonna be fun, and you can come, and the whole community is going to be there. So you can come, jump in, and ask more questions, and you get to know more people. I mean, in much more funny way. Yeah.
Great. We have a couple more minutes. Is anybody have last minute questions? Again, you can post in the chat, or if you prefer, you can just speak to ask questions.
Yeah, hello, can you guys hear me?
Go ahead.
Yes, go ahead.
Yeah. Yeah, so I just thought it's easier just to say it. Just out of curiosity, how did you guys just come across with this idea of kind of identifying that AI and natural language processes not really targeting languages?
So I did not hear well. Chris, have you heard it?
He asked, how did we come to the idea, like how do we come across the idea that AI and NLP is not really targeted to African languages?
Oh, well, yeah, I think I also.
Well, on the personal side, it came from trying to yeah, checking the website, for example, for Fon and seeing that there isn't much on Fon. On the research side is it came from like, so we entered NLP and then we tried to see what's being done on NLP. We tried to
Yeah.
follow the trend. And then at some point we realized that many of these models and these results are only showing for English or German, French. So there's like these specific languages that are being used. And there is few, not no, but few African languages that are being done in this research. So that's how we came across it.
Yeah, and also after or during the ITR 2020, Jade, which is a co-founder of the group, of the community, a very lovely woman, she shared a plot of the number of research that have been done in NLP. And in Africa, we did not even cross 1%. So 1% of NLP work or research done in the world, not even 1% were focused in Africa. So that was also motivation actually, like to change that tendency and to put African languages, Africa in general, more on the NLP map. So yeah, Masakhane we started I think in 2019. So I would say it's still a pretty young group, but like the desire, the motivation that every member has made it I think quite successful, like for that short time period. And we won the Wikimedia Foundation Research of the Year award. So yeah.
No, yeah, that sounds good. No, what you guys are doing is amazing. Thanks.
Thank you so much for your comment. We appreciate it.
Thank you very much.
Great. Thank you. Thanks a lot. Again, thanks Chris and Bonaventure for the presentations and share the insight on that. And it's really great. This is a virtual event, but I still want to kind of like to give you guys a virtual, visual a round of applause. So for those on the still, connected, if you can turn on your camera, if you want, or turn on your audios, or you can clap in the chat. Give them a round of applause.
Thank you so much.
Yeah, this is great. Thanks a lot. With that, it's concluded today's event. Thanks everyone for joining us. I hope you learned something. I hope to see you again in our next event.
Thank you very much for having us. It's an honor to be here.
Yeah, I share the same words. Right. So you can follow us on Twitter, Chris and I. That's where basically we share our ideas, our works, and everything. Masakhane is also there. I don't know. One second, I think I can share the tweet of Masakhane if you want to.
I've already shared it.
Yeah, you can post
right.
the information in the chat, and also for the the session recorded, you will everyone will receive the notifications when the video is ready.
Yeah, so just make sure you follow us, and then you can discuss more, share more ideas, and then see how everything goes. But thank you. It was an honor to be here, and I hope you gained something from it. And just say wonderful project. Thank you so much.